Prove from the first principles that the derivative of 4x is 4. Let f of x is equal to 4x, and to find derivative using first principle we use this formula. So therefore f dash of x is equal to limit h tends to 0 and then f x naught plus h. We will put this f x naught plus h into function, and the function is 4x. So there is therefore 4, and we put x naught plus h in x, then minus f x naught. So now we put x naught into function. So function is 4x, 4, and we put x naught into x divided by h. Okay, now the derivative is limit h tends to 0. Now let me expand this. So it is 4 x naught plus 4h minus 4x naught over h. This 4x naught and this plus 4x naught will be cancelled out, and we have limit h tends to 0, and we left 4h over 4. Sorry, 4h over h. This h cancelled out, and we have just 4. Therefore, the derivative, or we also write this symbol as well, is 4 of the function 4x. Second proof from the first principle that the derivative of x cube is 3x squared. Now the function is f of x is equal to x cube. So to find the derivative, that is f dash of x, we use this formula, limit h tends to 0, h approaches 0. So now we put x naught plus h. So the function is x cube. So therefore x naught plus h whole cube. Then we put x naught into function, that is x cube, and it will be x naught whole cube over h. So now the limit h tends to 0. So let's expand this. So you should know that x naught plus h whole cube. So the formula is, I put this cube over here, cube will come over here, and then plus 3, then it will be x square, and there will be h power 1. Then 3, we reduce the power of x and we keep on increasing the power of h, and then we have just h cube, because the now x will have power 0, and something power 0 is 1, so we will not write that. And you should remember these coefficients 3, 3. It is 1, 3, 3, 1 for cubic expansion. Okay, so now let me use this here. So it will be x naught cube plus 3 x naught square h plus 3 x naught h square plus h cube. So you can observe here, here we can write h power 0, and h power 0 is 1, so no need to write that. So the power of h is keep on increasing. Here we have h power 0, here we have h power 1, h squared, and then h cube, and here h cube and x cube, and the power of x is keep on decreasing, x squared, x power 1, then we have x power 0, x power 0 is 1. Then we have this one, minus x naught cube whole divided by h. Observe here, this will be cancelled out. So what we left here, limit h tends to 0. So we left this portion. And you can observe here h is common, h is common, h is common here. So what we do here, we will take h common, it is 3x naught square plus 3x naught h square. We took h common, so it will be h square because we have taken h common, divided by h. This h and this h will be cancelled out. So whatever we have left, limit, let me write it in here, h tends to 0, 3x square, 3x naught square plus 3x naught h plus h square. So we left this, put bracket. Now we'll put h0 in this. So we have h here, so it will become 0, h here, it will become 0, and we just left this. So the answer is 3x naught square. Because we don't have any number to put into x naught, so we will write here 3x square. So this is the derivative of the function x cube. The third question and the fourth question, it is for practice for yourself and see it whether you can do it. The question number 5. Okay, now we apply this formula now, and we put x naught plus h into this, and the function is kx cube. K is a constant, so constant will remain outside, and we will put this x naught plus h into x. So this cube minus, then we put x naught, just x naught into x, k times x naught, and it will be cube because there is a cube on the function. And we forget one thing, that we should put limit as well here, limit h tends to 0. Okay, so next, f dash of x is equal to, so limit h approaches 0, so just expand it. Okay, okay, so we have just in the last question, see this expansion is x naught cube plus 3x square h plus 3x h square, we put x naught here, plus h cube, and then this one, don't forget to write this as well, x naught cube. There's a cube on x naught, it is cube is not on the k, and over h, and then limit h tends to 0. So just normal, just look at here, just multiply this k with the inside, so it will be k x naught cube plus 3x square hk plus 3x naught h square k plus k h cube, and then minus k x naught cube over h. And now see this will be cancelled out with this, because one is positive and other is negative. Now you observe what left after this cancellation. H is common, so take h common, 3x naught square k plus 3x naught 1h and k, and plus h cube, this one divided by h. This h cancelled out with this. Okay, now whatever is left, we will put h0. So there is no h here, so it will be written like as it is, x naught square k, and but here the h is here, so it will become 0, it will become also 0, so we left this. So it means the derivative is 3, let me write k first. Suppose x naught is given, the point is given in the question. Suppose the point is 2, so in that case the derivative will be I will put 2 in the x, 3k, x naught is 2, so 2 square, so 2 2s are 4, 4 is a 12, it will be 12k. So then derivative will be 12k if point is given, x naught is given.